is X-ray study of crystal structures. So generally crystal lattice or space lattice. It is a three-dimensional space where all the lattice points are arranged in a regular orderly manner. Then space lattice contains smallest unit cells, smallest portions, which are called unit cells, repeating units. Okay, so structure of the crystal that is clearly explained by X-ray diffraction methods. The size and internal structure of the unit cell and arrangement of lattice points in the unit cell. So all are explained by X-ray studies method. So X-ray diffraction studies, they gives size and internal structure of unit cell and arrangement of lattice points in unit cell are explained by X-ray diffraction studies. Okay, so generally X-rays, these are electromagnetic radiations propagating in the space in the form of wave. So X-rays, they are propagated in the form of wave. Okay, so why? Because these are electromagnetic waves, electromagnetic radiations. Okay, so they propagate in the waves. So X-ray waves. Okay, X-ray waves. So these are electromagnetic radiations. Okay, and here all the X-rays which are electromagnetic radiations, they exhibit interference. Okay, interference of X-ray waves. They are generally in two types: constructive interference and destructive interference. For example, if you take two parallel X-ray waves, strength of one X-ray wave gets reinforced by another X-ray wave. That type of interference is called constructive interference. So generally X-ray waves exhibit two types of interference. Okay, so X-ray waves exhibit two types of interference. One is constructive interference and another one is destructive interference. Okay, so constructive interference, destructive interference. So X-rays, they exhibit two types of interference. One is constructive interference and destructive interference. So interference. So what is interference? If we take two parallel X-ray waves, okay, so here intensity of one wave that can be modified due to the superimposition of another wave. Okay, so intensity, that is strength of one wave that can be modified by superimposition of another wave. So that phenomena is called interference. Okay, so interference, two types: constructive interference and destructive interference. So coming to constructive interference. So in constructive interference, one wave reinforce the intensity of another wave. Okay. So here strength of one wave that gets reinforced by another wave. Okay. So this type of interference happens when both the waves are in same phase. If both the waves are in same phase, we observe the constructive interference. Okay. So one wave reinforce intensity of another wave during superimposition. So what is interference? If you take two waves, strength of one wave that gets modified with the superimposition of another wave. So strength of one wave gets changed with the superimposition of another wave. So that change may be in constructive manner, destructive manner. So in constructive manner, reinforce takes place. So strength increases due to the superimposition of another wave. So if we take two waves which are in same phase. For example, this is one wave. Okay, first wave. Then this is second wave. Okay, so this is wave 1 and this is wave 2. If both get superimposed. Okay, so superimposition takes place. Crust of one wave gets superimposed on crust of another wave. So this is crust and this is trough. Peak is crust and depression is trough. So crust of one wave gets superimposed over another wave. If you place this wave, wave 2 on wave 1. So crust superimposed over crust and trough superimposed over trough. So this is called interference. And we get a new wave. So this is resultant wave. If we take amplitude of this wave is E and amplitude of new wave is 2E. Okay. So this is constructive interference which takes place when waves are in same phase. So in phase. So that is constructive interference. And a destructive interference. So destructive interference takes place when waves are not in phase. Okay. So for example, if you take a wave like this. Okay. Then another wave like this. Okay. So this is wave 1 and wave 2. If both are superimposed. Okay. So due to the superimposition of these two waves which are not in phase, no result is obtained here. Okay. So no signal is obtained here. Interference. No signal or no resultant wave is obtained. Why? Because both are not in same phase. So this kind of interference that is called as destructive interference. So to study the structure of crystals by using X-ray diffraction method, both the waves must be in same phase and they shows constructive interference. Basing upon this, Bragg derived an equation to explain the structure of the crystals. Okay. So the wavelength of the crystals and also interplanar distance of the crystals. Okay. Why? Because all the atoms or lattice points, they are arranged in orderly manner. Okay, in the form of layers. Okay, so distance between layers of the crystal and wavelength, that is explained by Bragg's equation.